So here's the first example. A sound wave travels 340 meters per second in air. An ambulance emits their alarm at a constant frequency of 1500 hertz. Firstly, find the wavelength of the sound wave and the perceived frequency of the ambulance passes a stationary observer at 20 meters per second. So you can go ahead and try this problem, and then when you're ready, come back for the solution. Okay, so fairly straightforward question 1, I should hope. We're given the actual frequency at 1500 and the speed of the wave as 340. So V is just F lambda. So lambda is just V divided by F, so 340 over 1500. So we're not going to use it for the calculations, but it's handy enough to get sort of collected working. So 340 divided by 1500 is 0.23 meters. And that's the wavelength as required for part 1. Now part 2, the perceived frequency of the ambulance past the stationary observer at 20 meters per second. So I'm actually going to relabel these variables real quick. So C is actually 340, V is 20, and F is 1500. Now, as it's going towards the observer, the frequency would increase, so the denominator is C minus V. So I'll write that F prime is FC divided by C minus V. So we'll sub stuff in. So F prime is 1500 times 340 divided by 340 minus 20, so 320. So that means that F prime is 1500 times 340 over 320, and it's 1594. So a little bit louder, or a little bit higher frequency, not louder, but not by much. 94 hertz isn't too big of a difference. And that's one example of using the Doppler effect.